So it says calculate delta G for the reaction above at minus 50 degrees C and 675 degrees C. And we know that delta G equals delta H minus T delta S, and we have 3 hydrogen plus 2 nitrogen yields 2 NH3, which is the same reaction that we've been dealing with in several previous problems. So in a previous problem, we already found the delta S for this reaction. And we actually also found the delta G for this reaction. But the problem was that this is the delta G at standard conditions, which is 25 degrees C. We now want to find it at minus 50 degrees C and 675 degrees C. So we can use the table, products minus reactants, to find the delta S. And we find that the delta S naught for this reaction from 2 questions ago is equal to minus 198.1 joules per K. Okay, now because we don't want this in joules, we want it in kilojoules, because the delta H is going to be in kilojoules, we can view this as 0.1981 kilojoules per K as the delta S for this reaction. And that should of course still be negative, because when you convert to kilojoules, it's still going to be negative. So the next thing we want to do is we want to find the delta H. So the delta H is found the same way as all the rest of them. It's just products minus reactants. So it's the N, the number of moles, times the delta H of formation of the products minus the summation of the N, the number of moles, times the delta H naught formation of the reactants. And you'll remember that when we did this before for delta G, the delta H is also 0 for elements, and we're forming 2 moles of product, so we essentially just doubled the enthalpy of formation because we're forming the products from its elements in this reaction. So the delta H naught for standard conditions of this reaction is N, which is 2 moles, times the minus 45.9 kilojoules, and that gets the delta H naught of this reaction to be equal to minus 99.8 kilojoules. So we just doubled the 45.9. So again, we found this delta S previously, although you can do it this exact same way, except replace this for S. Notice that the S's for the reactants are not 0, so you'd actually have to subtract out some terms, and when you do that, you'd find this. Well, now we could find this for A at minus 50 degrees C. But remember that minus 50 degrees C is actually, you have to add 273 to that. This is actually going to be 223 K. So minus 50 degrees C is 223 K. We just add 273. Now we can use delta G equals delta H minus T delta S. Now, before we do this, think about what temperatures this thing might be spontaneous at. So our delta G, or excuse me, our delta H is negative, which is favorable towards spontaneity. Our delta S is negative, which is not favorable towards spontaneity. So in this case, for this minus T delta S term to become more positive than delta H, we want to have high temperatures. So at relatively high temperatures, this reaction may not be spontaneous. Whether 675 degrees C is a relatively high temperature, we have to do the math to figure it out. But let's take a look. So if we look at delta G here, it's delta H minus 99.8 kilojoules minus T, 223 K times minus 0.1981 joules per K. And when we do that math, we find that delta G is equal to minus 55.6 kilojoules. Because delta G is negative, the reaction is spontaneous at this temperature. So this is a relatively low temperature, making this reaction spontaneous. Let's look at B. B is going to be 675K. So now we need to add 273 to that. Sorry, it's 675C. We need to add 273 to that to make it K, which is 948K. So we need to check this out at 948K. Delta G equals delta H minus T delta S. So we have a much higher temperature, which means that this entropy term may actually overwhelm this and become non-spontaneous. But let's check. Delta G equals minus 99.8 kilojoules minus T, this time 948 K, times the same delta S minus 0.1981 joules per K. And we find that delta G is equal to 88 kilojoules. So now delta G is positive, and this is non-spontaneous. So at minus 50 degrees C, it's spontaneous. At 675 degrees C, this reaction becomes non-spontaneous. Again, the enthalpy term is favorable because this is an exothermic reaction. However, the entropy term is unfavorable. So at higher temperatures, it does become non-spontaneous.